Hello and welcome to an introduction video to the GenA system with T.Mackow. The GenA system is a computationally creative system which uses a genetic algorithm. This video will cover how the outputs are created as well as a few example runs. Alright, so to open the project, just double click on this package.bluej file, and I'm going to run it first because it takes a while to run, and while it's running I'm going to briefly go through the code, and then hopefully when I'm finished explaining the code it will have finished running. So to run it, just right click and click on main, okay, and this will start running. So it creates the initial generation and then it says running generations, please wait, and then these dots will slowly go up. So inside the actual code, so the main function initially creates the first generation, and it does that using the generation generator methods and the candidate generator. So each generation has 100 candidates, and each candidate is created in here. After that, each candidate in every generation is rated in the candidate rater function, which can be seen here. And what this basically does is it goes through each candidate, and depending on what the notes are and what values each note has, so for example here, if the note value is 001, which is a C, then the candidate gets a score of 5,000 added to it. And here, so that's if the candidate starts with a C, and here if it ends on a C, then it will get a score of 10,000. These ratings are to do with what octave the notes are in. So generally octaves 4 and 5 are favoured most highly, and 3 as well, and the really low octaves and really high octaves get a low score added to them, so that the octaves in the middle ranges are favoured the most. A similar sort of idea is done with the note durations here, as well as here with the actual note values, where they all get a score of 10 apart from this second C, which gets a score of 5 because I don't want the outputs to be overrun with C's, but then I do want there to be more C's than other notes because it uses the C blues scale. And then that's about it. Then it takes so these averages are used more for debugging purposes. So I could see the average for each generation, which was used to generate the graph in the report. But basically, these ratings are added up into like a cumulative percentage for each candidate, and then a random number is picked between 1 and 100, and the candidates with higher scores will represent a larger percentage of that 100, meaning that they're more likely to be selected for the crossover algorithm, which is the next thing that occurs. So the crossover algorithm takes the array and picks 2 candidate solutions and splits them at a random point, and then basically breeds them to produce 2 new children. And this is done for each candidate until a new generation is created. This new generation is finally given into this mutate function, which across the entire generation, so anywhere in the entire generation, it will take with a 1% chance, it'll take a single bit and just invert it. So if it was a 1, then it becomes a 0. If it was a 0, then it becomes a 1. And then this process is basically done 20,000 times, because that's how many generations I have chosen to run this for. Then the final generation it also gets passed to the candidate rater function, but this time with this little true variable, which takes it on a slightly different path and basically allows the program to finish. And when that happens, the program also generates a MIDI file using that Java music class, and gives it a song name, and then also prints it all out. So if we scroll down to here, we can see how the phrases are made here, and the chords are actually made up of two different phrases, but yeah, and then the names are just randomly selected from this list. So I think that pretty much covers all the code. If we now go and see how the output looked like. Okay, so it's finished. So the program successfully completed 20,000 generations. That's great, and it's decided that candidate 69 is the best one. Here we can see a visual representation of the output. So we can see that indeed it begins on a C and ends on a C, which is what the criteria generally favored. Then this is just saying that the MIDI file was created, and a MIDI file called Ocean Blue was created. So if we can go and listen to that. So that just gets created here in this folder, and if we just right click, and then I'm going to play that in Windows Media Player. Alright, and then so that didn't sound too bad. More examples are here. These examples I'll include as well. So here's just another one for the video. Alright, and yeah, that's basically those are a couple of output examples, and that's my system. Thank you for listening.